Good evening everybody. I welcome you all to this another edition of Clad exam preparation. We were covering exam number 6 and we were on to question 18. But before going on to question 18, I want to revisit question 4. So this was the question 4 which we have discussed in the previous exam, but I want to explain it in a better way. So the question 4 says, what is the value in feedback answer after the following code has executed? So this is a for loop in which there is this feedback, and then this initializer terminal of this feedback node has been taken one loop out and the initial value is given 1. So count is 4. So this loop will iterate 4 times, and for the first iteration the one over here, which is the input initialized value over here, will be given at the outlet of the feedback node, and the first value would be 1 multiplied by 2, and that will go to the feedback answer. Let's see the math and let's run this program in a slow motion. So this is question 4 block diagram, and this is the math. So before going on to the execution in slow motion, let's see the math. So according to the math, we will have 2 multiplied by 1. 1 is the initialized value over here. 2 multiplied by 1 will give feedback answer as 2 value output at the feedback node. Then 2 into 2, this would be acting as the inlet on the feedback node 2, and then 2 multiplied by 2 will give 4, and then again this value is feedback at the inlet terminal of the feedback node, and this would come at the outlet terminal of the feedback node. Then 4 will be multiplied by 2 will give 8. Again 8 would be fed back, and 8 multiplied by 2 will give 16. So that completes the 4 iterations, and the output at the feedback answer would be 16. So this would be the final answer over here in question 4. Let's see this in slow motion. So this is the same thing in the question which I have done on the program, and now I am going to run it in the slow motion. I am going to do the single stepping of this question. So first step, all inputs as 0. Next step, feedback takes the initialized value as 1 and feeds it back to the multiplier terminal. Then multiplier terminal multiplies it with the 2, and then the output will be 2, which is available at the feedback node. Similarly, other steps would be happening. 2 output at the feedback node multiplied by 2 gives 4. Again 4 is fed back. 4 is available at the output of feedback node, which is multiplied by 2, and output is 8, and 8 again fed back. 8 multiplied by 2 gives 16, and then the execution stops happening further and we have to exit. So we exit. So the final answer is 16. 4 times the loop iterates and the final answer is 16. So over here choice C is 16, which is the correct answer. Now let's quickly move on to question number 18, from where we are going to start today's class. So question number 18 says, which of the following statements is true regarding the execution of the following code. So let's see the code. So this is a file writing code. There is a open create replace vi which is wired as create, and there is a prompt to enter the file name. See that there is no path wired onto the open create replace file vi. So that means the program will prompt the user for entering the path. Then there is the write file vi. So this will write hello world to the file and will close the file further with the close file vi, and then if there is any error, that will be represented by the simple error handler pop-up notification. So we have to see which of the options regarding the execution of the following code are true. The first option says the string hello world will be written into a new file named by user. The option B says if the user selects an already existing file, the old data will be overwritten by the new data. So this option B is not correct, because there is a option only to create a file. There is no option to replace the file or old data would be written. So this is not the correct answer. Then C, if the user selects an already existing file, the VI will produce an error and stop execution. This is correct. So option A and option C are both correct. So the correct answer for this is D. Both A and C are correct. So let's see the answer for this. Question 18. So the question 18 answer is D, which is correct. So D. Next question, which combination of words correctly completes the following statement? Unlike dash, which display only the most recent array of values, return to them, dash update periodically and maintain a history of the past data. So this type of question we have done earlier. The first dash is graph and the second dash is chart. We have already talked about the update mode of charts and the graphs, and the history context of charts and graphs. Question 20. What is the value in X after the following code has executed? Write down your answers. This one is a very straightforward question. So 100 is square root, so that gives 10. 20 minus 10 gives 10. 10 is not equal to 10, that is false. So 10 is not equal to 10, so that will give false. So that will increment 1, means this option will work, this option will work. So then 10 will be incremented by 1 and this will go to the output and display X as 11. So the correct answer is C, which is 11. Let's see the answers. Question 20, the answer is C. So the correct answer is 11. Next question. Which of the following statements about the connector pane is true? First option, it says it only shows terminals available for transfer to sub-VI. Means we are transferring data, give the data to the sub-VI. It only shows terminals available for transfer from the sub-VI. Means only terminals available for outputting the data from the sub-VI. Both of these statements are not correct because there are terminals for inputting the data and terminals for outputting the data. So these both statements are not correct. Outputs must be placed on the left and inputs must be placed on the right. This option is also not correct. There is no written criteria that where we should place the inputs or outputs. We can place the inputs or outputs left, right, up or down. So the correct option for this is none of the above. All the above statements are wrong. Next question. If number equals minus 49, then what is the result in square root value after the following code has executed? Write down your answers. This is very straightforward question. This is a case structure and this is the selector terminal. These are the two cases, true case and the false case. What will happen? Number selected is minus 49. So minus 49 is less than 0. It is not greater than or equal to 0. So the true case will not execute, the false case will execute, and when the false case executes, this one button dialog will pop up and it will show error negative number, and simultaneously minus 99999 will be shown to the output at the square root value. So the correct answer for this is minus this, and the dialog box with error message will be displayed. Let's check the answers for this. For question 22. Question 22, answer is C. So this is the correct answer. Which of the following statements is true regarding the code in the loop shown below? So this is a while loop and this is the continue if true condition, and this is wired as false, and there is 100 millisecond time delay, and this is the iteration terminal which is going out of the loop with a non-index tunnel. So iteration will have the value of I. So first option, the loop will execute once and the iteration terminal will output a value of 1. So the iteration starts from 0. Let's first see what will happen in the program. In this program, since false is wired and the while loop will have to execute at least once, so it will execute once and check for the condition. The condition wired is false, so this loop will stop further iterations, and I would be having the value 0. So 0 will be outputted at the iteration. So this first option, the loop will execute once, up till this it is fine, and the iteration terminal I will output a value of 1. So this is wrong. The value of output would be 0. Next option, the loop will not execute and the iteration terminal will return a null value. No, this is not the correct option. The loop will execute infinitely and the program will have to be aborted. No, this will also not happen. The loop will execute once and the iteration terminal will output a value of 0. So this is the correct option. Next question. Let's check the answers. This is question 23. Question 23, answer is D. So this is the correct answer. Which chart update mode plots new data from left to right and then clears the chart and plots the newer data? So this is scope chart. We have talked about this earlier also. What are the results in maximum value and maximum index respectively after the following code has executed? So it will give the maximum value. Firstly, we have to see what is the maximum value. Maximum value is 7. So the maximum value over here would be 7, and the index starts from 0, 0, 1, 2, 3. So the maximum index would be 3. So the option would be 7 and 3. Correct option is D. Let's check the answers. Correct option is D. Next question. In the figure below, item G is A N. Item G. What is this? So this one is quite straightforward. This one is a tunnel and this one is a non-auto index tunnel, means last value tunnel. So the correct answer is D, tunnel. Description and help information for a VI may be placed. It can be placed in the file VI properties and documentation and on the block diagram or front panel. So both the options A and B are correct. Next question. Which of the following block diagrams could produce this result in waveform? So we have to see what is being plotted on the graph. Firstly, we have to see what are the increments on the x-axis. So it is 0, 1 and 2, means 1 increment. And what are the values on the y-axis? It is starting from 6 and going up to 10, and the values are 6, 8 and 10. So let's see now the code. So all the codes are plotting with 1 increment, that is fine, and so values have to be 6, 8 and 10. So we have to see what is happening in each of these codes. Each of these codes, the iteration is getting multiplied by 2, those values are getting indexed, and then the output array, in the output array we are taking the array subset. So we have to see that the values firstly should be generated from 2 to 10, because 5, all the loops are having 5 as the count terminal, so the loop will execute 5 times. Iterations would be 0 to 5, 0 to 4. So we have to see the values should be generated from 2 to 10. So only the increment values would be generated from 2 to 10. So option B and option D seems to be correct. Now we have to see what values are generated. So 2 multiplied by 2 will give 2, then 2 multiplied by 1 will give 2, 2 multiplied by 2 will give 4, 2 multiplied by 3 will give 6, 2 multiplied by 4 will give 8, 2 multiplied by 5 will give 10. The same thing is happening in D, but now we have to see the index. In B, the index is taken as 1, so that means from 4, and 3 values are taken, so that would be 4, 6 and 8. But over here in option D, index is taken as 2, so the values taken would be from 6, 8 and 10. So the correct option over here seems to be D, 6, 8 and 10, which are plotted over here. So from this we infer that option D is correct. So let's see the answers. I might be wrong. This is question 28. So question 28, the correct option is D. So this is the correct option. All the values generated from 2, 4, 6, 8 and 10. Index 2, that means values are taken from 6 and 3 values are taken. So 6, 8 and 10 are taken and plotted on the waveform graph. That's why we are getting this graph 6, 8 and 10 with the increment of 1. All are having the increment of 1. Next question. What is the value in result after the following code has executed? So this is a very tricky question. So in this string value, the values written over here are in the form of a string. So this value is being scanned using the scan from string function, and floating values are being scanned. Also the initial scan location is given as 11. So write down the answers. So we have to count from where the initial scan location is. So VOLTS gives 5, then a space gives 6, then DC gives 8, then a space gives 9, then plus gives 10, and 2 gives 11. So we have to start scanning the code from the point over here. So the LabVIEW will see the input as 0.50e plus 2. So if this is the input LabVIEW is seeing, so the input seen by LabVIEW, if %f as the format specifier is taken, so that will be given as 50. So the correct answer for this will be 50. I have made this code and we can verify it from here. So this is very interesting. The same thing I have done. So this is 50. So what will happen if we put it here as 10? When we put it here as 10, so it will take the position from 2.50 into 2.50 e plus 2. So 2.50 e plus 2 gives 2.50 into 100, so that will be scanned as 250. So that's why the result is 250. Again, if we take the location as, instead of 11 we take the location as 12, what will happen now? If we take the location as 12, so we will have the result as 5000. Now how does this 5000 coming? Because the value would be taken as 50 into 10 raised power 2, because e plus 2 means 10 raised power 2. So 50 into 10 raised power 2 gives 5000. Now let's increase one more line, one more space. Let's put it as 13. So if we put it as 13, so the answer would be 0. Why the answer is 0? Because the scan location is shifted to 0 e plus 2. So 0 e plus 2 means 0 into 10 raised power 2. So that will result into a 0. So this one is a really tricky question and a good question to do. So correct answer is 50. Let's check the answers. Question 29, the answer is B, and B answer is 50. Question 30, the main disadvantage of using the VI architecture shown below is. So this one is a general VI architecture in which there is a startup phase, then there is the main application phase, then there is a shutdown phase. In the main application phase there is a while loop and there are two case structures, and in which the first case structure action 1 code is executing, and in the second case structure action 2 code is executing. Simultaneously there is a 100 next millisecond multiple delay of 100 milliseconds is there, and then the stopping of the while loop is there. So what is the main disadvantage of using this type of VI architecture? So the first option says there is no way of shutting down the VI during execution. So this is a wrong saying, because there is stop terminal. You can always press the stop terminal and stop the loop. So this option is not correct. You cannot use wires to pass data between the case structures. This option is again not correct. You can use the wires to pass data from one case structure to the another case structure in the loop. The block diagram can become very large and hard to edit and debug. So this option can be the correct option, because if you put some design pattern in this particular case structure and another design pattern in this case structure, so this code can become very large complex and hard to edit and debug. Next question. All of the following statements regarding the index of arrays are true. The index is used to access a particular element of an array. This statement is correct. The index ranges from 1 to n, where n is the number of elements in the array. So this is not correct because the index ranges from 0 to n minus 1, where n is the number of elements in the array. Next, a 2D array has both column index and a row index. So this is also correct that a 2D array has both column index and a row index. So the option which is not correct is B. The index ranges from 1 to n, where n is the number of elements in the array. Next question. VI templates reduce programming time by providing a start point for the several common VI types. This is correct. Automatically generating code for the user. This is not correct. There is a software called Signal Express which automatically generates code according to the hardware connected in the LabVIEW environment, but VI templates don't do this. They don't automatically generate code for the user, then allowing the user to save portions of their own code for use in later applications. This is correct. You can design your own VI templates. So option A and option C, they are correct, and we can have both A and C as the correct option. So option E is the correct answer. Clicking in which areas of the following figure allows you to move the cursor on the plot? So there are 4 areas shown as A, B, C, D, and if you want to move the cursor, which of the options can we avail? So A is for adjusting the plot legends, giving the different colors, styles and other things. This is not related to the cursors. C is also not related to the cursors. C is actually the graph palette for zooming in and zooming out of the graphs and other things. B and D are the correct options. These are actually the cursor legends. So option A is correct, that B and D are the correct options. Question 34. Which of the following will allow you to have multiple plots on a waveform graph? So first option, bundle two 1D arrays of X and Y data together for each plot. Then build an array of these clusters and wire it to the waveform graph indicator. So the question requires that you have to have multiple plots on the waveform graph. So there are two 1D arrays. One is having X data and one is having Y data, and you want to plot them together on the waveform graph indicator. Mind it, this is not XY graph, this is waveform graph indicator, and option 1 says to bundle them together and then build an array of these clusters and wire it to the waveform graph. So this option does not seems okay, because when you are putting them as bundles of two 1D array and then building an array of these clusters and then you are wiring it to waveform graph, the waveform graph will not accept this as a data type. Then option B, build an n-dimensional array of data with each plot in separate row or column in the array, then wire the array to the waveform graph indicator. This can be correct option because multi-dimensional array can be used as an option for wiring the data into the waveform graph indicator. So this is the correct option. Then bundle the elements of each waveform into cluster and build an array of these clusters, then wire the array to the waveform graph. This is also correct because we can specify the initial time, the increment, and the uh, array into a cluster. We bundle them as a cluster, as a waveform into a cluster, and then we can have an array of these clusters and wire it to the waveform graph. So that will also create a multiple plots on the waveform graph. So the correct option is B and C. So the correct answer is D. Before checking the answers, let's first check the answers for question 34. The correct answer is D. Correct answer is D, both B and C. But let's see how this actually pans out to be. So let's see this question 34. I have made this question 34. So let's close question 4. So this is the question 34 program. In this we have used the B of this option. Build an n-dimensional array with each plot in a separate row or column in the array, then wire the array to the waveform graph indicator. So this option we have implemented over here using this. This is a build array function, and we have wired it. These are two arrays, and we have combined them in a single we have combined them using the build array, and we have created a two-dimensional array. So this is a two-dimensional array in which each row is a particular data, x data and plot 1 data and plot 2 data. Let's create this data. Now this data is plotted to the waveform graph, and this appended data is over here, and then the same data, choosing as the 0 as the initial time, 1 as the increment, and the data x, let's mark it as the x data and y data. Let's put it as, this is the x data, and this one is the y data. So both of these data are actually put onto the build array and this bundle also, and then a build array of these bundles is created and put on the waveform graph too. So you will see that both of these will generate the same graph. So when I run this program, so see, both are generating the same graph, and the values are actually, the first values over here are the x values, and the second values over here are the y values. We can also verify them, creating an indicator for this as the x array data. This is x array data, x data array. This one is x data array, and over here we can create another array. This is y data array. So we can verify that these two data are actually become the rows in the 2D data. So this is the X data and this is the Y data. So when I run this program, see that this X data is over here. These are the same values which are the values over here, and these are the same values which are the values over here. So I have combined these two data, X data and Y data, X array data and Y array data, into a appended array data, and this appended array data is plotted onto the waveform graph 1. And similarly, I have combined the X data with the bundle function, giving the initial time, the increment, and X data, again bundling initial time, increment, and Y data, and combining them together. These two bundles are combined together using the build array function and plotted onto the waveform graph. So both are generating the same data. So these are the two ways of plotting the same data. So that's why the option over here is written: build an n-dimensional array of data with each plot in a separate row or column in the array, then wire the array to the waveform graph indicator. This option is actually implemented over here. This is the option which is implemented over here. Now the next option, bundle the elements of each waveform into cluster and build an array of these clusters and wire the array to the waveform graph indicator. So this option is implement over here in these two, and data is plotted over here. So both ways you can plot the data and you will get the same results. So the correct answer is both B and C. Both of these options are correct. Question 35. Which of the following could generate the following waveform graph? So we have to see the waveform graph first. So this is the waveform graph having values from 0 to 1. Random values are generated, and we are having the increments from 100 to 101, just one increment, and we are having values on the x-axis from 100 to 104, and a total of 1, 2, 3, 4, 5, 6, 7, 8 and 9 values are there in total. So we have to see which of the following codes will generate this type of graph. So values are starting from 100. So option C is not correct because the initial value is starting from 1 over here, and this is not the correct option. And D is also not the correct option. The initial value is starting over here from 0.5. So we have to focus on A and B. So 100 initial values, both are generating random numbers. Random numbers range from 0 to 1, that's fine. Both are generating 9 values, that is also fine. Now the increment over here is 0.5 and increment over here is 1. So if we see the graph closely, we see that the values are being plotted at an increment of 0.5. So first value is at 100, the next value is at 100.5, next value is at 101, then 101.5, then 102, 102.5, 103, 103.5 and 104. So this option seems to be correct with the increment of 0.5. So the correct answer is A. Let's check for the answers. I might be wrong. This question is 35. Question 35, the correct answer is A. So this option is correct, A option. Starting with 100 and increment of 0.5, plotting the random numbers, plotting 9 random numbers. Next question, to operate a series of frames in a set order you would use a. So whenever you are going to operate a series of frames in a set order, you would require a sequence structure. So the correct option is D. Which of the following statements is not true regarding the figure below? So this is the for loop, this is the input array, and count terminal is not wired, and the output is given to the output array. Both the tunnels, the input tunnel and the output tunnel, both are auto indexed. So let's see the options. It is not necessary to wire the count terminal because auto indexing is enabled. This is very much correct, because of auto indexing the loop will iterate, and it will depend on the number of elements in the input array how many times the loop iterates. Elements of input array enter the loop one at a time. Because auto indexing is enabled, so this statement is also correct, that the elements in the input array will enter the loop one at a time. Next option, output array is same size as the input array. This is also correct, because whatever elements are entering, they will be exiting through the auto index tunnel. So the number of elements entering over here in the input tunnel will be equal to the number of elements entering and getting out of the tunnel through auto indexing will be the same. If you disable auto indexing on the right side of the for loop, the output is still a 1D array. So this option is false. This is not correct option, because once you disable the auto indexing at the output array, we will have the last value only. So this option is false. So for question 37, you have D as the answer. Let's check the answers. So question 37, the answer is D. So I am going on to the last question for today. In the figure below, the value at item G during the fourth iteration is. So this is a while loop with a stop wired to the stop if true condition, and 2 is the input, and this is the tunnel, and this one is not a auto index tunnel, and this value is being added with the iteration and given to H. So what is the value at G? The value at G would be 2 only. So let's see the answer. This is question 38. The answer for question 38 would be B. So this one is the correct answer for question 38. So this was the last question for today. I am sitting here for 2 minutes. If you have any queries, you can ask, and I will try to resolve your queries. Okay, thank you so much for attending this session. I hope you have liked this session.